T115 Algorithms and Programming. So in this video we're going to be looking at recursive or repeating functions. So the function is recursively defined as an operation on a set of natural numbers including 0 as shown below. So here we've got our function f of n, and it's equal to, when n is equal to 0, it's equal to 0. Our output of our function is equal to 0. And then when n is greater than or equal to 1, we can use this function to determine what the function's output is. So what is the value of f50? Is it 1250, 1275, 1325, or 1225? So let's have a look and see if we can analyze this. The value of f50 is calculated with a recursive function. Here f50 means that n is equal to 50 from our expression on the previous slide. Given the expression in the text of the question, when n equals 1, 1 is going to be returned, as the value of f of 0 is equal to 0. And in other situations, the value of fn minus 1 plus n is returned. Thus, the equations hold as shown below. So, when n equals to 1, we said f of 1 is equal to 1. When n equals to 2, f of 2, we have our value for n plus f of n minus 1, so f of 1. So this is equal to 2 plus 1. When we have n equals to 3, we have n, because n is equal to 3, so 3, plus f of n minus 1, so f of 2. F of 2, we've defined up here, is equal to 2 plus f of 1, which is equal to 2 plus 1. So we can write this as 3 plus 2 plus 1. And you can continue this expression as far as you want to go. So when n equals 4, we have 4 plus 3 plus 2 plus 1, or 4 plus f of 3. And we can extend this all the way up to when n is equal to 50, which is the value we want to look at. So this is 50 plus f of 49, which is equal to 50 plus 49 plus 48 plus 47, all the way to 1. And so this is going to be the output of our answer. However, this is quite a tricky method, as it's going to involve lots and lots of addition on a calculator. So let's look at a slightly more simplified version of how we can calculate this. For this specific function, f of 50 can also be calculated using the formula of a linear series of natural numbers. So here we can say that f of n is equal to n plus 1 over 2, and this will give us a correct value for f of n. So let's just check this formula from the previous slide, where we had n equals to 3, or f of 3 is equal to 6. So here n is equal to 3, so we have 3 times by 4 divided by 2. So this is f of 3 using our new formula, and this is equal to 6. So here we have the correct value coming out of our formula. So let's use this to calculate f of 50, and what we find is that it's 50 times 50 plus 1 over 2, which is equal to 2,550 over 2, which is equal to 1,275. Therefore, B is our correct answer. So, as we said on the previous slide, our answer is B, and here we've learned how to calculate a recursive function where we have a defined n.